You are listening to The Vocal Technologist. Spoken tech for your ears.
If you're building, well, just about anything in modern software or infrastructure, you know the ground beneath your feet isn't just shifting, it's tectonic.
Right. It feels like every week we get slammed by some new breakthrough or a new security crisis or a huge geopolitical move that just changes the whole game.
It's a lot to keep up with. So our mission today is pretty simple. We're going to try and pull out the core strategic insights you actually need to know right now.
We've kind of boiled it down to three main threads. First, how the actual physical map of global infrastructure is being redrawn.
Then some of the critical security threats that are sort of hiding in plain sight.
And finally, how AI is changing the very definition of what a skilled engineer even is. So let's jump in. Where do we start? The geography of the cloud.
Yeah, let's start there, because we have to talk about digital sovereignty.
It's a huge topic. And it's not just about data residency anymore, is it? It's about control, jurisdiction, and, trust. That's a massive deal for governments in Europe.
And the cloud providers are clearly responding with some serious engineering. I'm looking at AWS making its European sovereign cloud generally available.
The first region is in Brandenburg, Germany.
Right. So when they use that word sovereign, what does that actually mean operationally? What's the reality?
It means they are building a completely new trust boundary. I mean, this infrastructure is designed so that every single operation, all the support, physical access, it's all managed exclusively by EU residents.
So it's not just a different data center. It's a legal and an employment partition.
Exactly. It completely changes the trust model for the public sector or, say, regulated financial services. It takes away that risk that data could be governed by non-EU laws.
Okay, but hang on. At the same time they're building these partitions for political reasons, they're also trying to stitch themselves closer together.
You're talking about the Google Cloud and AWS cross-cloud interconnect.
Yeah, exactly.
It's the paradox of the modern cloud, right?
Right.
Fight for the customer, but collaborate on the plumbing. They jointly engineered this thing.
So it's a managed, private, encrypted pipe between their VPCs. But I have to ask, for someone listening right now, isn't this just vendor lock-in with extra steps?
That's a very fair question.
I mean, are they really making multi-cloud easier, or just making it easier to keep data moving within their own ecosystems?
I think the operational reality for big companies is that multi-cloud is it's inevitable. You get it through mergers, or you just use the best tool for the job.
Sure.
So this partnership gets rid of all that complex custom routing and manual VPN stuff. It's a standardized, high-throughput, private pipe. So yes, it keeps data between them, but it solves a massive friction point for engineering teams.
Okay, that makes sense. Removing friction is the real win. And speaking of friction, let's go from that macro geography down to the daily operational headaches. We saw a pretty big breakthrough from Pulumi.
Oh, the journaling feature. Yeah, this is one of those quality of life improvements that has massive scaling implications.
For anyone who's dealt with huge infrastructure stacks, you know the pain.
You know the pain. You make one tiny change, and the tool has to upload the entire state snapshot. Serially. It can take minutes.
And those minutes add up fast, especially when you're trying to push a fix.
Precisely. So journaling just sends the individual state changes in parallel. It's like sending a quick text update instead of mailing a whole book every time you fix a typo.
And the speed improvement is what, up to 20x?
For massive deployments, yeah. It means faster deployments, faster rollbacks, and fewer engineers staring angrily at a terminal screen.
I love any tool that eliminates wait time. And we're seeing that same focus on managing complexity with container registries too, like with DigitalOcean.
Their multi-registry support, yeah.
Yeah.
Letting a team manage up to 10 separate registries.
Why is that better than one giant one?
Isolation. The word is isolation. If you're a growing team, you need to separate staging from production or high compliance images from your standard app images.
It limits the blast radius if something goes wrong.
Exactly, and it makes auditing for compliance way, way cleaner. It shows the industry is maturing beyond just running containers to actually governing them.
That's a perfect pivot because all this incredible infrastructure relies entirely on trust, which brings us right into the, frankly, terrifying security side of things. Let's talk about that EKS security shock from the Bishop Fox experiment.
The BadPods experiment. Yeah, that was a gut check for anyone running Kubernetes on AWS.
So the finding was that a fully permissive pod, something you can easily set up by accident, Allowed for a complete container escape.
A complete escape. Even under the default AWS EKS security settings, the system was supposed to contain it and it just didn't.
So what was the actual mechanism? Was it some deep kernel flaw?
It was more insidious. It was an identity flaw. Once they got out of the container, they could move laterally, steal IAM credentials, and then boom.
Full control?
Full control over the node and the entire AWS account. And this wasn't some zero-day exploit. It was just a consequence of overly permissive defaults.
It just shows how a subtle flaw in a default config can undermine the whole security model. So if the defaults are dangerous, what's the defense?
Proactive hardening.
Yes.
You see Docker's response, right? They're offering free, open-source, hardened images.
Which means what exactly?
It just means they're stripping the base image down to the absolute bare minimum. Removing packages, setting strict permissions. It gives you a minimal attack surface, and just as important, you know exactly what code is inside.
A pure defense strategy.
Uh-huh.
And speaking of defense, we saw that huge investment from Anthropic into the Python ecosystem.
Yeah, $1.5 million to the Python Software Foundation. This isn't just charity, it's a strategic security move.
Protecting the supply chain.
Exactly. The money is for strengthening the CPython infrastructure and, crucially, for building proactive malware detection for PyPI.
It's like protecting the shared water supply for the entire community. Which brings us to the people who manage all this risk. I saw this really surprising finding that the most effective senior engineers, they sometimes strategically choose to let bad projects fail.
It sounds so counterintuitive, right? But it's all about influence triage.
Influence triage.
Yeah. A senior engineer knows their political capital is finite. It's like a credit card with a low limit. If you fight every mediocre idea, every flawed project, you just burn your credibility.
So when the real five-alarm fire happens,
No one listens to you. They've already tuned you out. So the skill isn't always being right. It's about strategic silence.
you only step in when the blast radius is catastrophic.
Exactly. When the cost of staying silent is way higher than the cost of intervening. If a project is just, kind of dumb or expensive, you let it run its course. You save your credibility for when it really, truly matters.
That is a masterclass in influence. And it's a skill you need because the systems themselves are changing so fast, largely because of AI.
Right, which brings us to how AI is totally transforming the engineer's role.
And the first big shift we're seeing is this rush towards typed languages, TypeScript especially.
It's a direct result of LLMs generating code.
Why? Why are type systems so critical now?
Because AI-generated code is fast, but it can be sloppy. It's prone to these subtle bugs. It can hallucinate function names, misuse variables, things that only show up at runtime.
So the type system acts as a safety net.
A high-speed, automated safety net. It catches those AI-introduced errors right away during development. It makes these huge AI-generated code bases actually maintainable.
That's the aha moment. The type checker is your first line of defense against the machine's mistakes. And if AI is writing all the boilerplate, the engineer's value completely changes.
It shifts entirely. The key skill is no longer writing code quickly. It's 1, defining the problem for the AI with absolute precision, and 2, expertly reviewing what the AI produces.
So we become problem architects and expert reviewers.
Exactly. Deep domain understanding and oversight, not just memorizing syntax.
And moving from human review to automated oversight, we have to talk about Meta's DRP.
Their root cause analysis platform. Yeah, it's a perfect example of using machine learning for operational scale.
The problem they're solving is mean time to resolution, MTTR. Every minute of downtime costs money.
A lot of money. So DRP is used by over 300 teams there, running something like 50,000 analyses a day.
And instead of a human scrolling through logs.
It uses ML workflows and historical data to instantly connect an incident to the most likely cause, like a recent code change. It's reducing their MTTR by a staggering 20 to 80%.
That's profound.
It is. This is something we've discussed on my show, The Vocal Technologist, as sort of the future of proactive incident management.
A quick technical warning for folks listening, though. We saw a flag about PostgreSQL arrays.
Ah, yes. The seductive convenience of
It
arrays.
seems so easy, right?
They're incredibly convenient. You can just stuff a list of things into a single column. But they hide huge architectural costs. They weaken relational integrity, and even worse, updating an array often forces the database to rewrite the entire row.
Which is a performance nightmare at scale.
A complete nightmare. They're best for read-only data, maybe some JSON metadata that doesn't change much. Not for core relational data.
Good specific advice. Okay, let's wrap all this up by looking at how these trends are maturing into what we call platform thinking. What's the forecast for, say, 2026?
The data is pretty clear. First, AI proficiency won't be optional. 94% of engineers are expected to need it.
Wow, 94%.
And second, the median budget for platform engineering teams is expected to double. This is a serious structural shift.
Doubling budgets means platform engineering isn't a niche anymore. It's becoming the central nervous system.
And there's a mandate to prove its value. To close this measurement gap of almost 30%, organizations want to see quantifiable business outcomes, and strategically, the focus is evolving from shifting left.
It's shifting down. Okay, walk me through that. Shifting down.
Shifting left was about process, moving security earlier in the pipeline. Shifting down is about building that value directly into the platform itself.
Intrinsic value.
Exactly. You're creating paved roads, reliable, pre-approved paths, so developers have real autonomy. The guardrails are built in, not bolted on.
But with all this investment, there's also that caution about the hammer, everything looks like a nail problem.
It's a huge risk, the risk of premature adoption. Jumping on Kubernetes or GenAI without a clear business need just leads to cost overruns and complexity. The answer has to be outcome-driven architecture.
Solve a real problem. Don't just adopt a shiny new tool.
Prioritize simplicity. We saw a great example with Air France KLM and their automation platform.
They shifted to policy-based guardrails, right? Using Terraform, Vault, Ansible.
Yeah, they basically codified their governance rules, and the result was dramatic.
What happened?
Infrastructure provisioning time went from days down to minutes. They slashed errors and could scale their multi-cloud setup securely. It just proves that automated codified policy is the path to agility.
Okay, and one last cool trick for the ops teams, a sneak peek into Python 3.14.
sys.remotex. This is a huge quality of life win for debugging.
So you can execute code inside an already running Python process in a Docker container or a K8s pod.
Without a restart, without a sidecar, without changing the application code.
That's incredible for remote debugging. You can just inspect the live state.
Exactly. It's the kind of quiet innovation that will save thousands and thousands of engineering hours.
We have covered a massive amount of ground, from the sovereign security that governments are demanding to the strategic wisdom of knowing when to let a project fail.
And the architectural shifts AI is forcing on all of us. I think the key takeaways are pretty structural. Sovereignty is redrawing the cloud map. Engineering skills are shifting from writing to reviewing.
And platform thinking is demanding measurable outcomes to avoid that complexity trap.
But all this complex strategy, it relies on one simple physical truth: that the infrastructure, the cables, the switches are available and under civilian control.
And the material we looked at contained this really powerful, chilling reminder of the fragility of the internet itself.
It's the highest stakes risk there is. Following internal unrest, the government of Iran deliberately shut down internet access for its citizens.
And the data was just terrifying.
A 98.5% decline in IPv6 address space. Overall traffic from major providers dropped by 90%. The country was almost entirely cut off from the world, a tactic to quell dissent.
It's a sobering thought. All the advanced tech, all our strategies, all depends on political stability. So here's the question to mull over as you design your next system. What happens to your strategy, your multi-cloud architecture, and your business when the infrastructure we all rely on becomes the means of control?
Spoken Tech for your ears.